Hello everyone. Okay, today we are going to discuss a little bit about our intakes and exercise questions. Okay, now see, first question. For the reactions R goes to P, the concentration of the reactant changes from 0.03 molar to 0.02 molar in 25 seconds. Sorry, 25 minutes. That means for a reaction, initial concentration was 0.03 molar and the final concentration was 0.02 molar, and takes the time to this transformations is 25 minutes. Then you have to calculate the average rate of the reactions using unit of both in minute and second. First of all, we know average rate equal to change in concentration by change in time. Since change in concentration means R2 minus R1, here R2 is the what? 0.02. This is the final, this is the initial. That means final minus initial, 0.02 molar minus 0.03 molar divided by 25 minutes. It will minus 0.01 molar and then by 25 minutes, and we will get 4 into 10 to the power minus 4 mole per minute. Now here concentration should not be negative. Okay, concentration should not be negative, though it is the negative, but we have to take as a positive quantity. Okay, because concentration cannot be negative. Now first, second one is that we have to convert this one mole per minute into what? Second. Okay, 0.01 molar, 0.1 molar. 25 minutes, 1 minute can have 60 seconds. That's why 25 minutes into 60. So this mole second inverse. Okay, mole second inverse. The next question. In the reactions 2A goes to products, the concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate that rate during this interval. See, then now here 2 moles of A reactant react to product to form products. As you know, average rate equal to minus, since it is concentration no in the reactant side, that's why it should be minus 1 by 2. 1 by 2 is the coefficient. Okay, coefficient of A, that's why 1 by 2. Change in concentration of A divided by change in time. Change in concentration means what? 0.5 to 0.4. 0.4 to 0.4 is the final, 0.5 is the initial. That's why 0.4 molar to 0.5 molar divided by 10 minutes. It takes the time 10 minutes, and if you just calculate, you will get 5 into 10 to the power minus 3 mole per minute. Okay. Next questions. For the reaction A plus B gives product, the rate law is given by R equal to K A to the power half B to the power 2. That means B square. Okay. What is the order? As you know, order is just simply the sum of the power of the concentration. No? Then if you add this 1 by 2 and 2, you will get 2.5. And 2.5 is the order of the reaction. Isn't it? Okay. Next question. The conversion of molecule X to Y. Okay. Conversion of molecule X to Y. That means a molecule is converted from X to Y. Okay. Where? X to Y follows second order kinetics. That means the order is second. Order is 2. If the concentration of X increases to 3 times, how will it affect the rate of the formation of Y? Now it's one condition is there. Concentration of X is increased to 3 times. Then what is the effect on concentration of Y? See, for the reaction X goes to Y, it follows the second order reactions. Therefore, the rate law becomes rate equal to K X square. Square means here 2. 2 is the order of 2. Okay. The concentration of X is what? Let the concentration of X is A. Let the concentration of X is, suppose, let concentration of X is equal to A. Okay. Then the rate concentration of X square equal to A square, X equal to A mole per liter. If it's concentration. Okay. Now if the concentration of X increases 3 times, then the new X, the concentration of X becomes 3 times. then obviously the rate equations will transfer to k into 3a whole square. Since it is second order reactions, 3a means 9k square. Thus the rate of the reaction will becomes 9 times. Hence the rate of the reactions y will increase by 9 times. Okay, obviously if it's 9 times, then obviously the formation of y will increase by 9 times. Okay, next see. Next question. A first order reaction has a rate constant 1.15 into 10 to the power minus 3 second inverse. That means rate constant for a first order reaction is given by 1.15 into 10 to the minus 3 second inverse. How long will 5 gram of this reactant takes to reduce to 3 gram? Okay, the concentration of the initial concentration of the reactant was 5 gram, but we have to calculate what is the time. Okay, what is the time taken to reduce to 3 gram? First, concentration of the reactant when the reaction was not started, that means at the initial concentration was 5 gram, but after the reaction it becomes 3 gram. Okay, and k is given 1.15 into 10 to the minus 3. As for the first order reaction, we know k equal to 2.303 by t log of concentration of r, not concentration of by concentration of r. Then obviously t becomes, if you just t goes here and k comes here, obviously 3.303 divided by k means 1.15 into 10 to the minus 3 log of 5 gram by 3 gram, gram cancel, 5 3 cancel, log of 1.667. and if we just put the values of log value of 1.667 and multiplied by this we get this value. This value means what? 444 seconds. That means 444 seconds needs, okay, to reduce 5 gram of the reactant to 3 gram. Okay, next see. Next, time required to decompose, okay, to decompose SO2Cl2 to half of its initial amount is 60 minutes. Remember, the concentrations of this SO2Cl2 reduces half, that means half-life period is T half is given 60 minutes. If the decomposition is the first order reactions, calculate the rate constant. As you know, for the first order reactions, the rate constant is given by or equal to 0.693 divided by T half. No, if we want to calculate then T half comes here and K comes here. 0.693 divided by 60 minutes. Okay, just do the multiplication, simple multiplication. We will get 1 into 925 into 10 to the power minus 4 second inverse. The rate constant should be this one. Okay, remember the simple mathematical part, no division, multiplication, additions I shall not discuss. Okay, do it yourself. Okay. Next question, see first our in-text exercise, first our exercise question is question number 1. For the rate expression of the following reactions, okay, determine their order of the reactions. First one is the when 3 moles of nitrous oxide gas react to form N2O, rate is given by KNO2. See, here is clearly given 2, no, that means the order is 2. Okay, see, as we know, rate R equal to, as we know, rate, let me write, as you know, R equal to what? R equal to rate equal to K into concentrations of any reactant. No, suppose reactant R. If it is 1, then first order. If it is 0, then 0 order. If it is 2, then second order. Similar case, if we just interchange K equal to what? K will becomes R by concentration of reactant. No, see, here is K becomes concentration rate divided by concentration of the reactant. Since it is second order, that's why here is 2. Now, as we know, rate is the mole per liter second inverse. Okay, rate is the mole per liter second inverse. Why? Because rate is defined as the change in concentrations divided by change in time. That's why concentration time. Okay, S is divided, that's why it's minus. Concentration, this one is time, and divided by the concentration of the reactant mole per liter, which is square because it is second order. Okay, written, and if you just simplify these equations, this term we will get liter mole inverse second inverse. Okay, similarly for this example, H2O2 plus 3I negative takes H positive, goes to H2O liquid and I3 negative. This one is the rate is given by K H2O2, that means hydrogen peroxide, concentration of I negative. That means it's also second order. It becomes the same, the unit of rate constant as this one. This one is rate given by K, concentration of CH3CHO, okay, is 3/2. That means order is 3/2. Okay. Now what will be the rate constant for this particular example which has the rate of 3/2? See here, this one is the reaction, order is 3/2. As K equal to rate by concentration of the reactant divided by 2. Concentration of reactant, for concentration of any reactant should be mole per liter, which has the power of 3/2. 3/2 is given. That's why if we just simplify this one, we will get liter to the power half mole to the power minus half second inverse. Okay, and this one do yourself. This one for first order reactions. Okay, next we'll see the reaction is, see this one. Decomposition of dimethyl ether leads to the formation of methane, hydrogen, carbon monoxide. The reaction is given by, and the rate of the reaction is given by K CH3OCH3 to the power 3/2. That means the reaction rate is 3/2. The rate of the reaction is followed by increasing the pressure in closed vessels. So rate can be expressed in terms of partial pressure dimethyl ether. Now see, now the rate is expressed in terms of partial pressure. No, as I explained, the rate with the help of partial pressure using the ideal gas equation PV equal to nRT, no, where the unit of concentrations becomes ATM second inverse. No, ATM is the unit of pressure and second is the unit of time. Simple thing here also, unit of rate equal to bar, since bar means the another unit of pressure. Here particularly in your questions bar is given. Okay, that's why here is written bar. Bar minute in minutes is another. Bar is the unit of pressure, minutes is the unit of time. Okay, that's why bar minute inverse. Therefore K becomes rate by this one, partial pressure rate is bar, meter minutes inverse, and this one partial pressure bar 3/2, and it becomes bar minus half, that means bar to the power minus half minute inverse. Okay, next see, in a pseudo first order hydrolysis of ester in water, the following reactions are obtained. Time is given, ester hydrolysis is given. At 0 time, the concentration of the ether is in mole per liter 0.55. At 30 second 0.31, at 60 second 0.13, 90 second 0.085. That means the concentration of the ether is decreasing. Now first one you have to calculate the average rate of reaction between the time interval 30 to 60. This one. Calculate the pseudo first order rate constant for the hydrolysis of ester. Okay, let's see. First one, the average rate during the interval of 30 to 60 seconds. Rate, average rate means the change in concentration, change in time. Okay, change in concentration C2 C1. C2 is the concentration at what? this one 30, C2 is 60, 0.31, 0.17, and this one is time 60, 30. Okay, as I just simply multiply or divide, we will get 0.14 by 30 mole per liter per second, and it will becomes 4.67 into 10 to the power minus 3 mole per liter per second. Okay, now see, for the first order reaction, that means first order reactions, it may be pseudo or normal first order reactions. The rate constant is given by 2.303 divided by k log of concentration of the reactant R naught by concentration of the reactant. Since R naught is given by 0.55 molar, that means initial concentrations. Okay, time is taken 30 seconds. Then k dash becomes 2.303 by 30 second, that means 30 log of 0.55 divided by log of divided by log 0.31. Okay, then it becomes 1.96 into 10 to the power minus 2. Now at 60 second, at 60 seconds, simply just in place 30 second we are using 60, and we will get at 90 second. See, at 90 second this becomes little bit higher. Now this one are the instantaneous rate. Okay, particular 30 second, 60 second, 90 second, but we need average rate. Average means if we get these three instantaneous rates, obviously from these three we can calculate the average rate also. Thus the average rate equal to just simply this one added divided by 3, we get 1.98 into 10 to the power minus 2 second inverse. Second inverse is the unit of rate constant for first order reaction. See, next one. (4.9). The reaction is first order. A reaction is first order in A and second order in B. In A it is first order, in B it is second order. Write the differential A rate equation. Differential means simple rate equations. dx by dt equal to k A1, a concentration of A1, sorry, concentration of A to the power 1, concentration of B to the power 2. Square means it is second order, 1 means it is first order. Okay. Second question, how the rate affected on increasing the concentration of B 3 times? If the concentration of the B increases by 3 times, then obviously if we square 3, then it becomes 9, no? That means then the rate will becomes 9 times. Since 3 square, if we put here k concentration of A, concentration in place of B 3B, then square, then 3 square obviously 9, no? It will becomes k 9 concentration of A, concentration of B. That means k equal to this one, suppose this one R and this one R dash, and it becomes R dash becomes 9 R, isn't it? Okay. Next thing, next question, 4.10 here. In a reaction between A and B, the initial rate of reaction R naught is measured for the differential initial concentration A and B is given below. This one given below. 20, 0.20, 0.20, 0.40. Here B is concentration of B in mole per liter 0.30, 0.10, 0.05. And R naught is 5.07 into 10 to the power minus 5, 5.07 into the power minus 5, and 1.43 into 10 to the power minus 4. Then what is the rate of the reaction with respect to A and B? Now see. As you know, rate of a reaction dx by dt is given by k, A to the power x, B to the power y. Okay. Now rate is given by what? Rate is 0.5. Okay. 5.07 into 10 to the power minus 5 into k, concentration of 0.8, this one 0.2, no, x, this one where B 3. Now also this one becomes 0.23, and this one, the help of this and this one with the help of this one for this, and this one for this. Okay, as is 2 0.2 0.1 0.2 0.1 0.2 0.3 0.2 0.3. X and y is the formula. Now dividing 1 by 2. Okay, this one equation 1, this one equation 2. Dividing 1 by 2, this one, see, this one and this one same thing, then it will become 1. This one same thing, then become 1. That's why we get 1 equal to k cancel, this one cancel, 0.3 to the power y by 0.1 to the power y. Okay, now see, 0.1 and 0.3 cancel, divided by 3 is no, we can cancel. How? So this is how this will becomes 0.3 divided by y, 0.1 divided by y. Okay, and this becomes 0.3 by 0.1 whole becomes y. This one divide cancel by 3, that means 3 to the power y. Here is 1 is nothing but, you can say 3 to the power 0, anything to the power 0 is 1, no, then 3 to the power y, and therefore y becomes 0. Y becomes 0. That's why y becomes 0. Now now see from this, okay, from this the concentration of A 40 and B is 0.05, and the rate is given by 1.43 10 to the power minus 4. From where we got, if you just apply the value of y equal to 0 in this equation, we will get this one whole term will be 1, no, anything to the power 0 is 1, this is terms, and x then divided by this one by this one. Now 3 by 4, this one taken as now 3. Okay, just putting the values of y in equation 2. Okay, in equation 2 we get the equation 3, 5.07 into 10 to the power minus 5 equal to k into concentration to the power concentration of 0.2x and 0.1 to the power 0, and the fourth equation is 1.43 into 10 to the power minus 4 equal to k into 0.4 to the power x, 0.05 to the power y. Since y is 0, that's why it is written as 0, and anything to the power 0 is 1. Divide 3 by 4, we get 1.28 equal to 1 by 2 to the power x. After getting this, we have to take log. Suppose log of this one and log of this one. Okay, log of this one, we get log of 2.8, and this one, what is the formula? Log of a to the power x has the formula of x into log of a. That's why x is here x, a is here 2, that means x into log of 2. Okay, next is therefore x equal to log of 2.8 divided by log of 2.0, that means log of 2.8 has the value of 0.4472, and log of 2 is value of 0.310, and it becomes 1.5, which is approximately 1.48. Therefore with the order with respect to the order of the reaction 1.5 with respect to A, and order of the reaction with respect to B is 0. Okay, the rest of the questions, okay, try to solve yourself, and if you getting something difficulties, then contact me, I will help you. Okay, thank you.